the autologous cell therapy specifically is designed for the harsh biological environment of the disc. And this is critical because the disc is probably one of the most hostile environments of the body. It's got very low oxygen tension. It's got minimal blood supply, acidic pH, poor nutrient and waste exchange, and most cells simply do not survive there. Our approach is very purpose-built and designed to actually solve the problem. And then we take that material that we harvest in a blood draw, and we bring it back to our facilities, which are FDA-certified facilities here in New York. And here's where we're fundamentally different. We culture these cells under a low oxygen tension called hypoxia. It's less than 5% oxygen, and that's very intentional. So by growing the cells in this low oxygen tension, we're conditioning them to survive and to function in the exact environment that they'll be delivered into after we've completed our product. And in simple terms, we're training these cells at altitude so that when they enter the disc, they're prepared to survive and to integrate and do the real biological work in those really harsh and hostile environments where your own cells just can't proliferate and they can't scaffold and they can't do what they're originally intended to do because of that hostile environment. So we also deliver a very high dose. So we deliver 40 million autologous cells, and that matters because cell dose matters, biological effect matters, and the survivability of the cells actually matter. So, when we combine those hypoxically conditioned cells with the patient's own autologous platelet lysate, which is derived from the blood draw that we talked about. The platelet lysate acts as both a carrier and a biological adjuvant that supports the cells and helps to signal and helps to the retention within the disc. It has a gelling effect. So once it's injected, it sort of gels so that the actual cells stay within residence. So the result is really a purpose-built regenerative product, which is designed to survive in the disc, reduce inflammation, remodel the extracellular matrix within the nucleus pulposa, address the root biological cause of degeneration, and not just simply mask the symptoms of the pain. This is not symptom management.